Okay, let's look at some more examples of linear systems, and these will be ones without a unique solution. So let's find the solution set of the following linear system. We've got three equations and three unknowns, nothing exceptional about it. And here's one way to transform it to echelon form. Now, we're going to add minus the first row to the second row, and minus the 2 times the first row to the third row, and that will cancel off this term, the x, the leading x in the first column, and the 2x in the first column. So that'll begin to produce echelon form. So let's see how this equation is produced. The minus x plus x cancels that. The minus z plus z cancels that. The minus 6 plus 8 leaves a 2, and the minus y plus 2y leaves a y. So you get y equals 2. Okay, the third equation is going to turn out to be y equals 1. Let's see how that's produced. Minus 2x plus 2x gives 0. Minus 2y plus 3y gives the y. And minus 2z plus 2z produces 0. And minus 2 times 6 plus 13 gives me 1. Right away, you see there's a problem. We can't have, there's no way to choose y, so the y is both 2 and 1. So we've got a looming contradiction here. And let's see how echelon form handles that. Well, to put it in echelon form, we need to get rid of the y in the third row, and we can do that with just minus row 2 plus row 3. And when we do that, we see we get here 0x plus 0y plus 0z. So we have the third equation becomes 0 equals minus 1. And it's a contradiction. So we can see that there's just, no matter what we choose for x, y, and z, 0 equals minus 1 is false. Therefore, in the original system, there's no way to choose x, y, and z to avoid the contradiction, because these two systems are going to have the same solution set. Okay, so here's the solution set is the empty set. Now this is all assuming that the Gauss's method is safe. It doesn't introduce new solutions or lose old ones. And so we still have to verify that that is the case. Let's look at a second example. Another case, another system with three equations and three variables. And we need the same, we will adopt the same strategy of first getting rid of the terms underneath the leading term in the first column. So we'll keep the first row, that is, and we will now add the first row and the second row. The x's cancel. Adding minus y plus 0 brings the minus y down to the second row. Adding 3z plus z produces 4z, and 3 plus 3 is 6. Okay, now we're going to add 3 times the first row to the third row to get rid of that first 3x term. Okay, well, you can see that adding 3 times minus 3x plus x does that. We have minus 3 plus 3 is 4y, and then 3 plus 3 is 9, 9 plus 6, 9 plus 7 is 16, and 3 times 3 is 9, 9 plus 15 is 24. And so this isn't an echelon form yet. We need to remove the minus 4y term in the third row. And this is the row combination operation that does that. So we repeat the first 2 rows. And then this minus 4 here with the minus sign here will give me 4y, and that will cancel this term. And the minus 4 with 4 will give me minus 16 and cancel that term. So I'm going to get a 6 down here. And in fact, the minus 4 times 6 will be minus 24, and minus 24 plus 24 is 0. So I have echelon form with a 0 equals 0 equation, which is fine. There's no contradiction. And so I can look for solutions of these two. Now, it turns out there's lots of choices because I have 3 variables and only 2 equations. So I can choose z here, any z I want, and then solve for y, and then take that y and plug it in, put the z I chose here, put the y I chose here, and found x. So for every z, there's going to be a solution. For example, if I choose z equals 0, I'm going to get y equals minus 6. And if I put that in here, if you look at the algebra more closely, you're going to find that x is 3, And if you choose z equals 1 and do a little algebra, you'll find another solution. Okay, so it takes a little work. So we'd rather have a more insightful way of describing all these solutions, and that will be our next project. But we can write down the solution set. It's not the most insightful form, but the solution set is the set of all triples, x, y, and z, such that the first equation and the second equation are both true. These are the equations from the echelon form system. We could have written this exact form down where we would have had this equation and this equation true. So these two, we've made a little progress in echelon form, but we need to still learn how to write such solution sets in a more revealing way. Now, you might think that the infinite number of solutions has something to do with the 0 equals 0 equation, but that's actually not true. Here's an example of a system with three variables and 2 equations, and you can bring it to echelon form, and you can see it has lots of solutions, but no 0 equals 0 equation. And that's it.